Because of its domestic abundance, low environmental emissions, and high energy content, natural gas has become a very popular and important fuel in North America. In these early years of the 21st century, about 1/4 of America's daily energy need is met by natural gas, including heating, electric generation, and industrial feedstock used for making products such as plastics and fertilizer. As the population swells, and with it the need for this cleaner burning fuel, so too must long-haul pipeline systems evolve and expand to keep pace with America's natural gas demand. Recently, Americans used more than 22 trillion cubic feet of natural gas in a single year. That's a tremendous amount of energy when one considers that 1 trillion cubic feet of natural gas is enough to heat 1 million homes for 15 straight years. Long-haul pipelines are the critical link between the often lengthy distances separating natural gas supply and major market areas. These major transportation systems generally differ from local distribution pipelines in several ways, such as the material composition and diameter of the pipeline, larger diameter steel versus smaller diameter plastic, and higher operating pressures versus lower operating pressures. When it comes to the operation of long-haul natural gas pipeline systems and the coexistence between the transportation systems and the public, operating companies place their focus in two primary areas: providing reliable service to customers and further minimizing the relative low risks associated with transporting a volatile fuel source under high pressure. Bureau of Transportation Statistics records have historically and consistently shown that long-haul pipelines have the best transportation safety record in the United States. Pipeline system accidents, which are reported to PHMSA, are rare, particularly when one considers the trillions of cubic feet of natural gas transported each year. But the industry fully understands the potential impact of a damaged pipeline and takes many measures to both maintain pipeline systems and prevent these accidents from occurring. Clearly, even though long-haul pipes have the fewest accidents among all companies involved in transportation, there's no rest on the best-in-class laurels. But one incident is one too many, and operators continually look for ways to improve the transportation of natural gas. The industry has built its solid safety record on a foundation of continuous improvement, and as a result, it has seen a percentage decrease in the number of significant incidents in the past 20 years, while the amount of natural gas moved in that time frame increased dramatically. Every step of the way, these long-haul pipeline systems are monitored around the clock by high-tech equipment and highly skilled employees. The basic process to transport natural gas long distances involves not only the specialized steel pipeline, but related measurement and pressure regulating equipment, compressor stations that compress the natural gas molecules to facilitate the journey, and control centers that monitor major operating conditions around the clock. Companies also repeatedly communicate with those living near pipelines, emergency responders, and other important stakeholders through various methods, while providing strategically located above-ground markers and other means to remind them of their mostly underground assets. As natural gas travels through the pipeline system, it is pressurized to varying levels inside the long-haul pipes to facilitate its journey. This is accomplished by squeezing the natural gas molecules by pressure known as compression. Compression of the natural gas molecules serves a twofold purpose. One, it reduces the size of the natural gas molecule by many times, thus increasing the amount of natural gas that can be transported in a given size pipe. And two, it provides a propellant force or boost to help move the natural gas through the pipeline system. Typically, compression of the natural gas molecules is required periodically along the route. This is accomplished by compressor stations, usually placed at 40 to 100-mile intervals along the route. The natural gas enters the compressor station, or booster station as it's also called, where it is recompressed mechanically and propelled toward the next active compressor station, where the process repeats. As a result, The highly pressurized natural gas moves through the pipelines at an average of about 10 to 20 miles per hour. Along its journey, measurement and/or regulating stations are placed periodically to help manage the flow of natural gas entering or leaving the pipeline. At these stations, mechanical pressure regulators are used as necessary to reduce the pressure inside the pipeline to match customer needs. This facilitates the transfer of natural gas to industrial customers and the distribution companies that deliver the product to millions of homes and businesses each day. The transportation of natural gas is often closely linked with the temporary storage of the commodity in porous rock formations or salt caverns deep underground. The underground geologic formations and associated above-ground operations equipment are connected by pipeline to various mainline systems. Natural gas storage facilities are important because they can temporarily hold large volumes of natural gas for later withdrawal during periods of high customer demand. In order to manage the natural gas that enters the pipeline and to ensure shippers receive the transportation and/or storage services that they've contracted for, sophisticated control systems are required. Centralized natural gas control operations manned by trained operators continuously collect, assimilate, and manage data received from measurement, monitoring, and compression facilities all along the pipe. Most of the data received by a natural gas control center is provided by supervisory control and data acquisition systems, better known as SCADA. SCADA is a sophisticated communication system that operates in real time with very little lag between measurements taken and the relay of the data to the natural gas control center. Measurements monitored and relayed include natural gas flow rates, operational pressures, and temperature readings, all of which are important to the assessment of the status of the pipeline at any given time. Alarms at these remote locations are also relayed to the control system operators. It's important for operators in the center to know what is happening along the pipeline system at all times. This allows for quick reaction to address and adjust to changing operating conditions. Operators with these computer monitoring SCADA systems often have the ability to remotely operate certain equipment along the route, such as compressor station engines or valves. But these operator actions are limited by safeguards and redundant devices. Adjusting compressor engines allows for the quick and easy adjustment of flow rates in the pipeline, while remote operation of valves allow for the isolation of certain sections of pipeline for maintenance or emergency response purposes in coordination with local operating personnel. Remote operating capability, plus the strategic local, area, or regional placement of trained employees, makes for the effective management and control of these long-haul natural gas transportation systems. For more information about long-haul natural gas pipelines, please visit the Interstate Natural Gas Association of America website at www.inga.org.